voice over IP, VoIP. We're going to make a detailed explanation, then we're going to talk about IP cameras, IoT, access points, all this stuff, because this is actually going to be our last video before we move on to AI. So I'm going to start a new AI course, and our focus will be only on AI for the coming months. That's it. AI engineering, agentic coding, agentic AI, and automations. That's it. That will be the focus of the channel. Okay, so this is the last. So I just wanted to cover this remaining concepts before I move on to AI. Okay, so voice basically is telephones. When we say voice, we mean IP phones. Let me show you here. We have image here. So Cisco IP phone, for example here. So this is an IP phones. Okay, if you notice in any company, you'll find this IP phones, right? This kind of IP phones. It doesn't have to be Cisco. We have Grand Stream. These two are actually the market leading, and not this two. There is more also. This is Grand Stream, one brand of IP phones, and there is Avaya also. IP phones. Avaya is actually the top right now, and the idea is it works by IP basically. It's going to get an IP. It's going to work. Okay, so let me show you a diagram. So what's the idea of this? So let's say we have okay, let me just copy this one. Okay, paste it here. Okay, let's say you have IP phones here. Let me just reduce the size, and let me paste one more here, and let me put another here, and let me just copy this one, copy this, paste it here, and paste it here. So this is how it looks like basically in a company. If you go to any company right now, okay, in a big company or medium-sized company, you'll find they have IP phones, okay, like this. Okay, and we have Cisco switch or whatever, any switch Cisco. I'm just going to use Cisco switch, but it doesn't have to be a Cisco switch actually. It can be anything. Okay, so let me just copy this one or put this one. Okay. Yeah, let me just put it here, and so let me just copy this one, and I'm just going to put this one here. Okay, I'm doing this so you can see visually what exactly happens before we start doing the labs. Okay, so we move on here, and yeah, so basically we will have also PCs. So I want to have PCs here. This is desktop PCs. Keep it, yeah, just open this in a new tab, and just the image actually we need. The image is gone, so yeah, we just need any PC, image of a PC. I just want to show you how it looks like in the real world before doing it practically. You have to see how it actually looks like, so you can see it in the where is the desktop PC? Okay, let me just open this one. Yeah, so let me just copy this one and put it here. Okay, this is PC. Okay, so I'm just going to put it here. Okay, and I'm going to put it here. Okay, I'm going to put it here. I want to show you exactly how it looks like in the real world. Okay, you have a PC. Beside it, you have a IP phone, right? Each PC you have a IP phone. Okay, we will assume for now, no need for this for now. So let's do 3 here. Let me go ahead and do this here for you, and yeah, so we can just understand what we need for this. Okay, so this is how it looks like in the real world. Actually, you will have on each table you will find one PC and one IP phone, right? So yeah, so this is an IP phone, okay, and this is a switch. So what we will do right now, there will be a cable that's connecting to the IP phone. Okay, the IP phone has 2 ports, one for PC, one for switch. Okay, so you can go ahead and type here IP phone ports. Okay, almost always you're going to have, like on most of the PCs, you're going to have like this. This is how it looks like. Okay, so open this here on a new tab. Okay, so I can just show you what it looks like in the copy this one. I will paste it for you in the here. No, I'm supposed to get the image, but it's copying something else. 1 second. Yeah, that's also yes. So we got this. Remove this one. Okay, this is the back side of the phone. Okay, on almost every PC or every IP phone, you're going to have 2 ports like this: one for PC and one for LAN. Okay, so this cable that's coming from the switch, you're going to put it inside the LAN. Okay, and from LAN, okay, from that's it. Okay, the switch is going to be connected to the LAN port inside the backside of the voice, the IP phone. And then you will ask, what about this PC, the second PC? You have 2 options. Okay, you can connect it directly to the switch, which is not recommended actually, which is not how it's done in real world. Okay, production environment, and so waste of cables. You're just pulling another additional cables unnecessary. Okay, because already they have your IP phones has a mini switch inside it. You can just bring a cable. Okay, just bring a cable and just connect the switch. I mean, one short cable connect the PC port here on one side and to the PC. Okay, so now both the PC and the IP phone are connected to the network. Okay, this is how it's done on the real world environment. Okay, so you're going to separate each one and put it on a separate VLANs. We have something called VLANs that we use to segment the network. And again, if you don't know about VLAN, you have to go through my previous course on CCNA. I explained VLAN specifically. It's used to segment or separate different traffic, broadcast domains basically. Okay, yeah, so I'm going to put the PC on a separate VLAN 20. Okay, and I'm going to create another VLAN also for voice, only for voice. I'm going to call it VLAN 10. Okay, for voice I put VLAN 10. For This is for the IP phone, and for the PC I put VLAN 10, VLAN 20. Okay, now we have two different VLANs. Okay, and on this port where it's connected to the switch, I'm going to configure here. Okay, I'm going to make it an access port. Okay, again, we have different types of ports. We have access ports, we have trunk ports. Okay, the difference is trunk port. The difference is access ports are used to connect. You're supposed to configure on the ports that you have connected your end devices, like PCs or VLANs. Okay, trunk port you should configure it where if you are connecting two same switches like this. Okay, and if you want because so it can pass the tagged VLAN. Okay, trunk is only used for tagged VLAN. Okay, tagged packets. Okay, so we need both switch this and this switch to know the VLAN information. Okay, so for that purpose we need to put this trunk port. Okay, here it will pass both the data, both tagged and untagged. Okay, the tagged is for the voice and the untagged is for the PC, for the data, right? Also, we will configure later on QoS. QoS is a protocol that allows you to prioritize some traffics, okay, data. So we have to prioritize the voice data. Always has to have more priority than the data, because voice has to be instant, right? Has to be fast, so you don't lose the packet. But data, you can make it less priority. Okay, and one more thing we need to understand is something we have we call I will, in terms of now your question should be like, what about this one, this IP phones, how it's going to get the IP? Okay, it's going to get IP from the router. Okay, I'm going to have a router here. Okay, and I'm going to put here Cisco CME. Cisco. Okay, CME is just a router. Okay, it's not any router. It's just this is an example of a CME. CME is like a router that can act as a router, and it can also be used for with IP phones. Okay, it's like a control like it's centrally, it can manage all the extensions of the IP phones. Okay, yeah, we can just copy this one. Okay, it's a special type of router. Not all routers. You have to make sure if it's, there are different types of routers that support IP phones. Some routers don't support IP phones. Okay, so we have to put it here, and I'm going to connect this one to the switch, which is here. Okay, so now that I connected the router to the switch, next step is I have to configure the HCP here. Okay, I have to configure the HCP pool. Okay, I'll use the HCP pool IP the HCP pool command, and I'm going to configure the HCP pool for voice here. Okay, on the router. Okay, because this router is going to have three responsibilities actually. It's going to act as a TFTP server, and it's going to act as a DHCP, and it's going to act as a it's going to act as both. Okay, so TFTP server is used to download and install the configuration files of the firmware, the configuration files of that is used, or the operating system that is used in the IP phones. Okay, Again, we are assuming that this is Cisco, but so the IP, the concept is actually similar. Okay, for all. Okay, so and the idea is I'm going to add the HTTP server here on the. I'm going to mention the IP ranges here, and I'm going to also mention the where it can find the FTP server here, this IP. Okay, I'll use something option 150, I think, option 150, and I'm going to mention the IP of, let's say, 192.168.1.1, which is this one, this IP itself for the router's IP. And I'm going to mention the IP range here, network, let's say 192.168.1.0.55.255, something like that, right? And yeah, I'm just going to do this. Okay, and I will add also default router, default gateway. Default router is just default gateway. Don't worry about the syntax, we'll fix it later. Okay, just try to understand the concepts, and this is how it looks like in Cisco configuration. I'm just focus on this one. This is new. We're just saying that we're just telling the IP phones this is our FTP server. Okay, yeah, so we are actually supposed to configure both the VLANs. Okay, we're supposed to create two, one for voice, okay, and one for data. Okay, this is for voice. Okay, this is for voice. Okay, and I think I'm supposed to create one more here, one more pool for data on the router. Okay, so I'm going to change this. I can change this one to 2 or something, and change the I don't think I should put 2 here. Let us go to the notes so we can understand it clearly here. So what is VoIP? I think I already explained. Instead of voice traveling over old telephone circuit, where voice becomes digital data, IP circuit travels through a network like a normal traffic. Okay, so that's what it is. Okay, so yeah, voice is just a data. Okay. Traditional phones, okay, traditional phone system, this old phone system, we use PSTN, analog lines, telephone exchange. Voice travel through a dedicated circuit. Okay, when we say about the old phones, we mean this one, analog phones. We have this old IP. These phones, these are not IP phones. It just travels through dedicated circuit. This is completely different. It's old. It's not used anymore. It's used in some companies. So VoIP systems. Okay, this is our focus now. It uses Ethernet, switches, routers, IP address, and protocol. Voice becomes packets. Okay, just like a normal data. Okay, so we're going to make a simple lab here. Okay, we're going to first start routing. Okay, and yeah, so yeah, we should focus first on the routing. Let us do the routing, and then we're going to put each branch under different gateways, and we'll use serial link between routers to communicate via this one. Okay, usable IPs only. Okay, and then I'm going to use routing protocol so that they can communicate with each other. Okay, so before moving on, let us do this. Let us do it practically. Okay, Cisco packet tracer. me download. No, I have it already. Let me just go here and let me do guest login. So I'm going to do this now. Okay, this is my lab. I'm just going to choose I'm not sure which one is actually, I think this one, 29 or might be 2811. Might be able to support okay, let's ask, does 2911 router modem is 2911, says. Let's use 2911 then. No need for this one. He said 2911 router is so let's use this router. Okay, let us go ahead and close this one. And okay, we have this router right now. So I'm going to use one switch here. Okay, I'm going to use two actually here. I'm going to use one switch here, and I'm going to try to make it simple by just using one IP phone here. That's it. One PC and one IP phone, because we just want to learn. Or no, I suggest we keep it like this for now, because the goal is just to understand exactly what is this. Again, you see what I'm doing? I'm connecting the switch with the switch port in the IP phone, and I will take one cable here from the phone to the PC. خلاص. And we'll do the same thing here as well. I'm just going to connect to the switch. I'm going to take it from the switch to the PC, and I'm going to take one cable from the router to the switch. And then I'm going to make a serial connection. I'm thinking of this one actually, serial. Let me try the serial connection from here. Okay, it must be the second one. Okay, I just choose this one. Okay, so for our purposes this lab is more than enough. Okay, we can practice what we need for now. Okay, I'm going to open this router. Okay, I'm going to say no here because I want to configure it manually, and I'm going to go ahead and type 115. Okay, but first let me write the IP. Here I'm going to put 192.168, or leave it or change it, make it 10.0.0.1. okay, and add here 10.0.0.2. so we will have yeah, and here I'm going to make 192.168.1.0.1 basically is the default gateway, and here it's going to be 192.168.2.0/24, and I think here we can make it .0/24. okay, so this is our network. So okay, so leave this one. Okay, I'm just going to pause the video because it's actually taking me out. So I think we can continue. So this is my topology and this is the IP. Okay, so now first thing I need to do is go to this router, click no, enable config T. First I'm going to go ahead and int do show int IP brief. Do show IP int. We have okay, I think we're not going to find here. We have how many ports here that are used? We can see here we have okay, I think there is a way to display, to view all the view show viewports. Yeah, this is the command I think. I don't know, this is no view. I think there is an option here to will allow you to show network information. No, there is a command here that will simply let you see all the but it's okay. This is gigabit 0. This is gigabit 0. Yeah, let's save this one as gigabit 0 by 0, so we don't have to do it again and again. This is also the same thing. This port is also gigabit 0 by 0, and this one gigabit 0 over 1. This is gigabit 0 over 1. This is the port numbers. Yeah. F01. So let me just put here F01, and here also F01, F01. Just so this thing will save us time. We don't have to worry about G01. We don't have to worry about the port number. F02, and here. Again here also F02. So that's about it actually. That is going to, now we can start the configuration. Okay. First I want to go ahead and enable the interface G0 by 0 and 1. I'm going to type range here, and I'm going to say no shut, so it will open both ports, and yeah, then exit this one, and then I'm going to start configuring the IP of int G001. I'm going to say IP address 192.168.1.0, no, .1 actually, because this is going to be my default gateway. Okay, again I'm going to go to the next one, which is G0, and the same thing, just change the IP here, make it 10.0. So now I have done this, and now shut as well, and close this one. Now I'm going to go ahead and create a routing protocol, actually. Router, yeah, you can use different routing protocols, but I'm going to use this one for now, so they can communicate with each other. Exit for now. Before moving on to the router, let me just focus on this one. Okay, before figuring this second part, we should focus on this one. Go to int G over 0 over 1. Okay, and give it yeah, I need to give it an IP here. Okay. G0/1 I already gave it an IP, so now I'm going to go IP DHCP. I'm going to create a DHCP pool now. Okay, I'm going to call it. I'm going to create two, I think. One for data. It's going to be network 192.168.1.0. Okay, this is actually what I wanted to know. I will create I think I should create one for both. Let me see how it is in the configuration. Let me go ahead here. So when we talk about switch port configuration, so yeah, I'm supposed to create different DHCP for IP phones. It's going to be this one, okay, and yeah. Okay, let's keep our focus on IP phones, because yeah. So for IP phones, okay, we're going to go ahead and do this one. Okay, IP DHCP pool voice. Okay, this is the network 1.0, and this is the IP. And this is option 150. Option 150 is basically the FTP server. It tells the phone where is the TFTP server. Okay, without it, phone cannot download the configuration. Remember, I told you all the phones are all the phone configuration are stored in the TFTP server, and for our purposes, usually it's going to be on the router itself. So we have to give this router IP to the phones as a FTP server. See, it's the same IP. So I'm going to do that now. Okay. Yeah, I'm going to go ahead and do that now. Okay. So let me go ahead and put the network here. 255.255.255.0, and I'm going to mention the default router. The default router basically means just a default gateway. 192.168. Obviously, is going to be our router, and next is going to be option in the scope question mark here, and I'm going to say option 150. The IP is going to be the same as the router. Okay, I'm supposed to say IP, then I'm supposed to mention the IP, write the IP of the router or the CME. Okay, and then enter. So now I'm done. Okay, so right now, okay, it should get an IP actually, the phone. Okay, if you go here and it's kinda off now, I don't know why it's off. It should be on. It's maybe because the port is on. Oh, wait. What's the reason? Why is it off? Anyways, it's okay. That's not our topic right now, so it should be on. But I think it's here, yeah. So I just started it manually, so we can. Right now it's just configuring VLAN. Okay. Right now we didn't do any configuration. We're just checking if it will get the IP or not. Okay, it's just saying configuring VLAN. Let's give it some time. Okay. If it will get the IP or not. We can check after some time, no problem. Leave it like this. Just wait some time and we'll see if it will get the IP or not. Okay, we can check back after some time. Okay, I have and from my side the configuration all is done. Okay, for this branch. So stuck on configuring VLANs. Okay, let's go ahead and do it. Okay, so now we've configured the IP, right? So let's me go through what we did in details. So you see, I just so we understand what we just did. So details. Okay, so voice VLAN. Okay, so why we need a separate voice VLAN? Voice traffic is sensitive to delays, jitters, and packet loss. So companies isolate voice traffic. For example, we'll have two different VLANs. We'll have VLANs for voice and we'll have VLANs for data. Okay. So right now, phone plus PC are on the same port. Cisco IP phones usually has switch port and PC port. We know already this. The phone acts like a mini switch. We know this also. So the switch port configuration, we need to make this, we need to add this configuration. Okay, we need to say switch port mode access and switch port access VLAN 20. This is the access for the PC. Switch port voice VLAN 10. Okay, this is for the voice. Okay, the port carries untagged traffic for PC, VLAN 20, and for tagged press for phone. So how phone learns the voice VLAN? When the phone powers on, what is my voice VLAN? The switch tells it using the CDP. Then the phone tags the voice packet with VLAN 10. Okay. So Cisco IP phones needs power. Okay, we have two method. Power adapter, this is the one that I just used. I just showed you there. But we don't have to use that in real world application. We can use something called power over Ethernet. That means switch sends electrical signal through Ethernet cable, much better. Okay, that means you don't need to set, you don't need to do this, what I just did. I just plugged it with a power adapter, right? If the switch is PoE, okay, when you connect the cable, it will automatically power on. It will send the electricity power to the phone and automatically power it on using the normal cable. That's what we call power or PoE. There are different types of switches. We have PoE switches and we have normal switches. So in our case, it was a normal switch. That's why we had to use a power adapter. But if it's a PoE switch, we don't need to use that. And the HCP for IP phones, these are the four focuses. IP phone needs an IP address, subnet mask, gateway. It needs a TFTP server. This is what we did with option 150. This one. Okay, we're telling it that the FTP server is where you can download your configuration files is on the router on this IP. Okay. So the router right now in our case is behaving like a phone system. Okay. What CME does is registers the phones, manages calls, assigns extension, control signaling routes. All this stuff is being done by the router. Okay, because this router has added functionality that can allow phones to manage phone systems. Okay, right now, before moving on, before doing anything, I think we should go ahead to the switch because the phone is still, it's looking for VLAN, right? So let's go to the switch and do that. Enable this one, config T, okay, int F02. Okay, I'm going to go ahead and put switch port mode access VLAN. We said 20, right, for the PC. No, sorry, I removed the access. Access VLAN does not exist, creating VLAN 20. This is good. Okay, so it's creating VLAN 20. Okay, And also at the same time, on the same port, I'm going to do switch port voice VLAN 10. So now it has both the VLAN 10 and VLAN 20. That's all I need to configure on the switch. Now we have separated both the switch and both the data and the voice. Okay, now the IP phones, as you can see, now it changed. It's saying configuring IP. Okay, it's saying configuring IP. Before it was just looking for VLAN, right? Now it's saying configuring IP. Give it some time, it's going to get the correct IP from our DHCP server, our router. Okay, so right now, okay, it's configuring IP. Okay, so okay, that is for the, yeah, just give it some time, it's going to work. Okay, so we're going to be configuring IP. So right now what I need to do is, here I did I did the DHCP pool for the voice actually, but we call it data. So let me just create another pool here, IP DHCP pool. I'm going to call it R data, so we can differentiate between it. Okay, because I just created for the still configuring IP. Okay, now we did this and we have given it the IP traffic, so the phone should be getting the IP, all is well. So okay, I think we have to do something here in this port F0/1. Switch port and yeah. Okay, let me go ahead and do something here. Okay, let me go ahead and turn it off. Let me connect it again, the switch, and restart it. Like, unplug the port and no. Okay, now put it back again. Power it on. Let's see what happens. No, still it's stuck on this. Okay, it's still stuck there, right? So let me power it on again. Yeah, let's go ahead and see this one. Let's see what happens. Okay, let's finalize now. Okay, so now it got the IP. Okay, how it got the IP is like get 1.2. The reason it was not working before is just simply because I have to configure router on a stick here. Okay, so this is what I did. I just went to created the sub interface here. Okay, I created the sub interface G0/1. 10 here, this port, and I created first I did encapsulation.1q, this one encapsulation.1q 10, okay, because this is for 10 VLAN 10, this is for the voice, and then I put the IP address 192.168, the default gateway. I put it on the sub interface instead of the main interface. Then the IP phone started to get the IP from the main port. Okay, but now if we check, yeah, whenever we open the okay, it's fine. So basically that's the idea. We have to configure a router on a stick in order for it to get the IP. Let me open it again here. Now remaining for us to go ahead and do the actual configuration of the IP phones. Okay, call manager express. Actually there is another system for the telephones to manage Cisco call manager for big large organization. We call it CUCM. Okay, the difference between CUCM and CME is CME is built in on the router. You don't need a special hardware for this. CUCM is centralized solution for large enterprise, thousands of users. Okay, but if your company doesn't have 1,000 users or more than that, you can just use CME. It's integrated to the router-based solution for small to medium business, typically up to 450 users. Most likely your company is going to be less than 450 users, right, who are using the phones. So you can just buy a router that can act as that has a integrated CME. It will act as a call manager for you. Okay, so simplify your cost, and also, yeah, you can use it as a router as well. So let me go ahead and continue here. Okay, now I'm going to go ahead and check here first. Okay, it got the IP right, but if we go here, I think we'll face issues. Okay, so let me just now that we know how to fix this one, okay, now it's time, I think, we test this out. I don't think we need different branches and all this stuff. I think this is just unnecessary for us right now. Okay, we just want to test the IP phones, see how it works. Not even PCs. Whenever I open any PC, I'm facing an issue actually. Whenever I try to open a PC, it takes me out. So now if I try to connect the cable, let me try to open this one. I get an error. You see this one? So I'm going to close. Okay, I'm not going to use the PC for now. Okay, I'm just going to go ahead and make sure the phones work. They can call each other, get the IP, and configure the extensions. And if we can do that, and while understanding the concept, it's enough for me. And let me just close this one, remove this network, remove this router. You can keep the switch, no problem. Put the switch here and put it in one network. Just on the switch, make it, yeah, that's fine actually. Just make it like this. Okay, and yeah. So also this IP, make it powered on. Add the adapter here so it's powered on, and here okay, so I'm just going to restart it, so or something, so we can start fresh basically. I want us to start fresh because I want to redo everything. I didn't save the config, so if I restart it, it's going to start fresh. Same thing with the switch, I think. No, with the switch, yeah, I think the switch, we don't need to do that. Switch is fine, the configuration is fine. Just let me open the router here. Okay. Yeah, maybe we can just see the IP. We don't have to open it, but it has to be actually DHCP, but it's not DHCP. I think the PC. So okay, let me just go ahead, enable this one, config. I'm going to redo what I did. T. Okay, config T. So I'm just going to go ahead and take this port, which is G0/1, right? I'm going to go ahead and assume that we have G01. I'm just going to put no shut. That's it. That's what I will do. Okay. Then I'm going to exit from G0/1. I'm going to create a sub interface, G0/1.10. This is going to be for the .10 is for the voice, right? For the voice over IP. I'm going to mention 192.168.1 and .0, or you can change also the IP. It doesn't have to be 1.10. It can be 1.10 here. Okay, so it can be like this. But before that, you have to do encapsulation dot 1.10. Then go ahead and do this and put no shut. Okay, and again I'm going to do the same for 20. I'm going to create another interface for 20. I'm going to make it .20, and I'm going to change this IP to 20. And once I do that, I'm just going to say no shutdown. I finished. So now let's create the DHCP pool for data and for voice. Let's start with the data. Okay, it's going to be network 192.168. We said the data is 20, right? 20.0.55.55.55.0, and default router for the PCs is going to be 192.168.20.1, and that's all we need for this. And for the voice, I'm going to create the DHCP pool for voice, and I'm going to put the IP.10, and the default default router also I'm going to mention 10 here, and then here one more configuration we have to do. This is very important. Option 150. I'm going to tell the IP phones where to find the activity server, which is this my router exactly, so it's the same here. I have to put IP here and exit. So I think on the configuration here is done, but on the switch we are supposed to actually put this one trunk F0/2. we're supposed to put it trunk, this port, because we're passing two different VLANs, right? Enable config T int F0/2. It's 2, right? Let's check here. Yeah, this is 2, so it has to be switch port mode trunk, and this is done. And here also we have to add F0/3. we have to make it trunk as well. Int F0/3, same thing, it has to be trunk, switch port mode trunk, so it can pass the tagged packets to the switch also. That's the only way the switch can know. For example, this sends packet, this can know switch. So, but this port has to be accessed F0/1 and F0/1. We have to put it switch port mode access and switch port access VLAN 20. Okay, and switch port voice VLAN 10, right, for voice traffic. Then exit. So now we should get the IP. Yes. Okay, this is getting the IP, this is not getting the IP. The reason it's not getting the IP is because I think I have to configure here as well. Same thing, right? Enable config T. Check this port number F0/2 and F0/2. Same thing I have to do here. Switch port mode access and no, 1 second. Remove this one. Switch port mode access. Switch port mode access VLAN. Switch port access. Yeah, you're right. Access. We're supposed to put this to VLAN 20, right? PC. PC is supposed to be VLAN 20, and voice VLAN 10 for the voice VLAN 10 for the. So exit here. Now you will see that this IP phone is also going to start to get the IP if the configuration is done. Yeah, let's give it time. It's going to get the IP. The PCs, I don't want to click on it, so let me remove it, because these PCs actually are making problems. They're not actually working for me, and they're just causing issues. Let me check the laptop if it will work. Check, or let me check an access point. No, let me check a laptop. Laptop is better. I will try a laptop. Maybe we will be able to fix this issue. I will try, but before doing anything, I want to see if everything is working properly. And here, this is getting correct IP, and this is not getting the IP actually. It's just saying configuring IP. So let me check what I did here. And switch port mode access VLAN 20, yes. The voice VLAN 10 for the, this should be working. Yeah, it's working. See, we got the IP. So both the IP phones already we got the IP. Okay, the laptops, I don't want to click it because it could actually cause problem for us. Okay, close the IP. But the laptop are going to get the IP from the other DHCP, from the data. But for now, let us move on and try to finish the lab, and then we'll try to check the laptops. So this is the main CME configuration. On the router we have to type this command, telephony service, so we can activate it. Here for some reason I'm getting this, which makes no sense. Why I'm getting 10.1 IP? Okay. Do show IP interface brief. Yes, manual up. Okay, so why DHCP server pinged this one? DHCP address server pinged .2. Okay, I want to go ahead and try this for a moment. Okay, so first command, then we'll fix the DHCP issue. So first command that we need to focus on is telephony service. This command we have to put. Without this command, it's not going to work as a CME. So just try IP. I think it's IP telephony. No, or try telephony. Let me just put telephony here. No, IP. So let's see what we have here. I think in some routers the naming is different, so I don't have that option here at all. I'm not sure if it's even supported by, no, it's not. I don't think it's okay, let me check the config. Uh, 2911 IP telephony command. 1 second. 2911 Cisco router telephony service. This one don't work. This command I'm trying to fix it, but it's not working for me. Telephony service. So it's giving me this error. Okay, let me try to exit here. No, let me do one thing. Let me go ahead and try another router, because this could be an issue with the router. I will try this. Yeah, so enable config t telephony. Yeah, so this router that I'm using actually doesn't support IP phones. So 2900 does not support IP phones, so I'm just going to remove it. Okay, let me just remove this one because it's making problems actually. This is 281. I'm just going to change the router here. Okay, this is going to be which port? F00. Okay. Okay, let me just do what I did there again. Int f0/0, do no shut, no, and int f0/0 dot 10. I'm supposed to do IP address 192.168.10.0.1.255.0 and okay, type encapsulation dot 1 dot 10 dot 1q 10 I think. And so now go ahead and go to the dot 20 for the data and put 20 here, and okay, add encapsulation dot 20 and 20 here again, no shut. So I'm going to create the HCP pool. Let's create for voice for now, just keep it voice related. Network 192.168.10.0.255.255.255.0 and default router. I'm going to create 192.168.10.1 and as I said, and don't forget the DHCP, the option 150 IP 192.168.10.1. So now exit. Let's just have a look at the IP phone if it's going to get the correct IP. But why am I getting this? Anyways, let's just check. Yeah, I think it got the IP. Yeah, 10.1. Okay, it's giving 10.1. Okay. I think I know what's the issue. It is yeah, it's giving 10.1 here. No, it's 10.3 now. Okay, so I think I need to exclude this 10.1 IP. One second, let me go ahead and IP or exclude it. I think I need to go ahead IP DHCP. Okay, yeah, IP DHCP excluded because it's giving, the reason I'm getting IP conflict is that it's giving that IP to the, yeah, so exclude the 192.168.10.1. so this is the router IP. I don't want to give this to anyone. IP DHCP and 255.255.255.0. But to whom exactly we're doing this? Okay, we can see now that it's actually excluded. No more ping issue or IP conflict issue. So this was the issue actually, because it was giving the my default gateway IP to the but now nothing is working. Now it's not receiving anything actually. I said exclude 10.1. Yeah, don't give 10.1. But let me check DHCP pool. Voice. Okay, so let me check here. It's not getting the. Still, it's just not getting the IP at all. Now that's the issue. Okay, after excluding, I think I'm supposed to set this again. Okay, so since it's already excluded, no, IP DHCP voice. Okay, so go ahead and put the network. I think I'm supposed to do it again. Yeah, network. You're supposed to exclude the IP before creating the pool. Network 192.168.10.0 255.255.255.0, and we have default router 168.10.1, and we have what's the last step we have here? Yeah, option 150 IP 192.168.10.1 exit. So let's see now. Just give it some time. It's going to distribute the IP. Okay, it's configuring the IP now. Okay, also let's go ahead and check this one, because I think, okay, do show IP and brief, no, config T. Let me check if it's getting the IP. It's still not getting the IP, so I'm not sure if it is the show IP interface brief. Not this one. Do show ROM, do show VLANs. Okay, the VLANs are actually created, so this should work. But why it's not working? Why I'm not getting IP? I'm not getting IP, no one is getting IP, so I think that this command is wrong. I think I'm not supposed to go ahead and do it. It's the router IP, it should work. VLAN 10, and let me see the switch configuration. Do show run. Okay, I did that in F0/1. I did all the configuration that I have to, and there is no issues here from my side. The issues with the configuration, so let me go ahead and do this. Good to know. IP exclude this one, so let me go ahead. IP, the HCP voice. We have network 10.0.0.network IP. I think we should do this inside. No? Okay. So no. Okay, this one. IP voice network 10 and actually this is supposed to be VLAN 10, not voice. The name, but I don't think the name will make us that much difference. But let's go ahead and do this. Or will it make a difference? Yeah, we are just getting the IP now. And it's giving me a conflict. I don't know why it's giving me a conflict, but it's giving me a conflict. Keeps changing. Keeps giving me different IP here. 3232. Okay, let us just try to fix the problem. Let's just do the extension telephony service. Done. Okay, this is the first command that we need to put. This will help. This will give you the option, take you to the config, where you can configure the phones. Okay, you can just type here. The first thing is actually we can specify the maximum DN, maximum ePhones. Okay, this is the maximum phone supported. Okay, you can specify maximum DN also is the maximum extension. Okay, then IP source address, the IP port. This is phone registers to this IP. Without it, phone never registers. Okay, we're supposed to put the IP of the router. Then create CNF files. This creates config files for the phone. Okay, let's go ahead and do that. First, max ePhones. This is the maximum supported phones. I'm going to say 10. The max DN is the maximum supported extensions, 10. And then IP source. Okay, I'm going to go ahead and type address. I'm going to type my no, one second, source address. There is a dash between them. I'm going to type my router ID. This router itself is the address, right? And then port, define the TCP port for telephony fallback. Keep it 2000. It's the default, right? And the last one, create question mark CNF file. Create XML for files. Okay. Enter. Clock is not set or synchronized. Retaining old version stuff. This doesn't matter really. That's it. This is the first configuration we need to do. Then when the phone powers on, okay, get VLAN. First it gets the VLAN information, right? Then it gets IP from the HCP, gets option 150, contacts the FTP server, downloads the firmware config, then registers to the CME. Okay, so right now we don't specify any extension rate. We just configure how many extensions, what are the maximum support extensions, and that's it. So now we can configure it using this command. ePhone 1. No, this is just yeah. CME identifies phone using MAC address. Okay. So ePhone DN just means directory number. This is the extension number. Okay. So I'm supposed to type ePhone DN1, first extension. I'm going to type the number 101 or anything, right? And this is just to link it, and so on. So let's go ahead and try that one. I'm going to type here. Let's define the extensions. We can just go ahead and exit here. Type ePhones. Okay, you have to yeah, ephone dash dn. First extension is going to be number 1001. That's it. That's all. Exit. Now this phone is going to get the first extension. For the second extension, okay, I'm going to say ephone dn. Okay, I'm going to say 2. Okay, for ephone dn2, I'm just going to say 1002. Exit. So now we have extensions. Now we just need to wait for the phones to get the extensions. Right? Yeah. So now we have something called Cisco IP Communicator. This is a soft phone. Like, you can download it and you can use it. It's cheap. Like, okay, DSP is digital signal processor, special hardware for voice processing, responsible for encoding, decoding, compressing, and transcoding. Okay, digital signal processor. Okay, so okay, this should actually work, but I'm not sure why it's not working. Yeah, I did all the configuration. That has nothing to do with anything. Okay, so let's check what is DSP. Digital signal processing. DSP, which specialized technical filters digital. I think it's inside the IP phones, or this is a chip that's available inside the. I don't remember where exactly. Is it inside the IP phones or CME? Inside IP phones. I think it's inside IP phones. Or okay, they serve different each location. Okay, they're available in both. Okay, IP phones contains built-in DSPs. Okay, digital signal processor for audio encoding and decoding, handset audio volume management. Well, CME also uses for heavy-duty tasks like transcoding and stuff. So that's the purpose. And now the extension, it's not actually getting the extension. Why not? Let me see the. I did the numbers. They should be getting the extensions already. I think there is some issue with the IP conflict. I think it's not going to work before we fix this issue. So this conflict, I want to fix it because I noticed this is actually a very common issue. Okay, let me fix this one and then we'll finalize this final theory. Okay, I'm actually trying to add it manually, so I need the MAC address for this to add it manually, but I don't know how I can get this one. Let me see the attributes, refresh. I don't have the MAC address here, so this is the problem. The MAC address is not available, but it should be done. It should have been got the IP automatically without me having to do this. So let me just power off this one and restart it. So let's see if it will get the extension automatically after restart. You can do it also manually using the command, just type ePhones ephone 1, whether it's 1 or 2, the number of extension where you define the number, and then add the MAC address manually. But I don't want to do that. But that's how it's done. Okay, so let's just talk a little bit about this so we can move on, and then we can move on. So we've said DSP is used for encoding, decoding, and stuff. And voice codecs, we have codec is a method of encoding voice. Okay, we have G711 and G729. G711 is 64 kilobits per second. It's for best quality. You have to use this one, but it doesn't have compression. This is the negative of G711. With G729, it's 8K kilobytes per second. It's compressed and saves bandwidth. Okay, if you don't care about bandwidth, if you don't care about best quality, it's better to use this one. Save bandwidth, G729. If you care about, this is the difference. Just compression is the difference. Okay, between G711 and G729 voice codecs. Why compression matters? Without compression, many codes consumes huge bandwidths. Okay, and we need to compress it. Voice quality, MOS, means mean opinion score. Okay, measures voice quality. 1 is terrible, 5 is perfect. Okay, just understand that's the meaning of MOS here. Analog versus digital voice. We have human voice is analog. Okay, router understands digital. Okay, so VoIP system converts the analog to the digital using sampling. Okay, it uses sampling to convert the voice, the analog, to digital. Okay, Nyquist theory, they explained human voice max frequency is 4000 Hertz. It needs 8000 samples per second. Okay, each sample is 8 bits, so 8000 times 8 equals to 64,000 bps, which is 64 kilobytes per second. That becomes G711. So yeah, so even after restart, nothing. Mac. So this is not working again. So the only, okay, I think okay, so right now what we need to focus on is let's see what happens here. So this is the thing, FXS and FXO, very important. FXS is foreign exchange station, provides dial tone, voltage and phone service. You connect analog phone to FXS. Okay, so this is foreign exchange station. Okay, so this is the port that where we connect the analog phone. FXO is foreign exchange office. Okay, connects to PSTN, telephone company, analog line. FXO receives dial tone. Okay, and easy memory trick. FXS supplies services. FXO connects to service. Okay, pillar is private line automatic ringtone. Example, voice port, this one, connection pillar, meaning as soon as handset lifts, automatically call extension 1010, used in reception, emergency. Private line automatic ring down. Okay, as soon as handset lifts, automatically call extension. Okay, elevators. Okay, this is what we call private line automatic ring down. It will automatically ring to this extension. Okay, this is private line automatic ring down. Yeah, let's use a repetition. Dial pairs, this most important part of voice routing is dial pairs, equivalent to routing tables for voice. VoIP dial pair voice 1 VoIP, destination pattern 2, session target this one. Meaning if extension begins with 2, okay, send call to this one, session target to this one. Okay, ports dial pair used for analog line, dial pair voice 2, ports destination pattern O2, port this one. Any number beginning with 0 goes to through analog ports. Okay, so dial pair basically are like routing tables. Okay, that's what we need to know. Destination pattern, we have 200. T means variable lengths. Okay, starts with 0, variable digit afterwards, usually for external numbers. Okay, so we have different features of the call. We have call forward, busy 1001. If busy, forward the call to 1001. That's what it means, call forward. Call waiting allows second call during active call. Okay, call waiting. Hunt group, same extension shared across users. Okay, it rings this one and it all rings, all the phone rings. Preference determines call order. Pickup answers another phone's ringing call. Okay, answer another phone's ringing call. Okay, park, temporary park call, another phone retrieves it. That's the idea. Paging, broadcast voice to all phone. It's like announcement. Okay, caller ID block hides identity. Voice protocols, we have SCCP, this is skinny, this is Cisco proprietary. SIP, this is industry standard, most modern systems use SIP. Okay, PSTN integration, they connected GSM gateway with SIM card. Purpose, VoIP users can call mobile phones and landline and receive call from outside. So most important concept to understand are basically networking first. Voice depends on the network, and HCP plus option 150. This is critical for phones. Yeah, we said we've learned this one practical also. CME acts as PBX. Yes, we know about this extension. We've played with this as well. And dial pairs, this voice routing logic. Try to know the difference. The entire call flow. When a user calls from 1001 to 2001 extension, this happens. Please, phone sends digits to CME. CME checks dial pairs. It's routing tables, basically dial pairs. Finds matching patterns. Routes call to remote peers, to remote router. Remote CME finds destination phone number. Phone rings. Voice RTP stream starts. RTP is the actual voice packet use. RTP. Okay. While signaling uses CSCP, SIP, and HTTP depending on the system, but the actual voice packet uses RTP. Show voice port summary. Show if phone registered. You can use this command itself now, but I don't know if it will work. No. Still you're not getting any extensions here. I want to add it manually, but I'm not able to get the MAC address of the phone. Okay, it is D352 5D43. D352 5343. Let's see. D352 5343. First one is, let me enable this one. Enable config T. Okay, ephone 1. Okay, this command I'm going to use to create MAC address, and I'm I'm just going to paste this one. Dot here 5343 dot here going to say 00DA maybe, but we will verify this one now. D0 D352 5D43 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 D352 5D43, and this is 0. I think this is it. MAC address is already assigned with ePhone 2. Okay, so if it is already assigned with ePhone 2, then why can't I get make a call? Let's see here, 1002. It's not actually working. Okay, 100 some issues there. I think it's getting the IP. Okay, so I think it's already assigned, so let me try this command. I'm going to do show IP phone, show ePhone registered, or do show ePhone itself. Let's see, it's telling you what? I think something is off here. It's, and this command IP DHCP binding DHCP show dialog peer voice. So I think we should stop here. Okay, I was able to resolve the issue. The main issue was the extension, the type. Here we didn't define the type 7960, and that was the issue. So let's go ahead. Here it's working. It got the extension 1001, and let's go ahead and try this one here still. So let's try ePhone 2. And let's type the button here. Type. We have to define the type of the 7960, the type of the phone. Type 7960. Okay, then only it will work. Okay, when you define the type, it's going to work. Because here actually registered the IP when I define the type, but also I have to link it, not only define the type, we have to link it. This button with there is one more here button, we have talked about it. This command, linking phone to extension, it's not going to work without this command. Okay, phone button 1 extension to 1, right? This one. So make it 2 2 2. Do 2 2 2. Let's see now. Button accepts button 1. Okay, 1 2 2. Done. So the phone is registered. So yeah. So we have to use the button 2. We have to just so we have to actually try to understand more about this one, get this command, and because without this it wouldn't have worked. Now it's working, but the most important, the key concept, the key command that we were linking the extension with the linking extension with DN. So command is used to directly map the first physical button on the IP phone to the first defined directory ephone DN. This creates one-to-one association with button 1 controls IP phone. To link the first button to the first extension, following configuration. Finds the normal ring for the button. To map multiple directories numbers to a single physical button, use the overlay. So yeah, so a single ephone DN is associated with, so this is the thing. Now it actually works. Okay, so let's say I type here 1001. So it's calling here, you see, it's ringing out, so it's connected. I can speak, it can speak. So that's the idea. So now I made we have learned how to configure IP phones in depth. Okay, but I want to, I think this is enough actually for in terms of for beginners. Actually, this beginners to intermediate, this will be enough. Just we have to learn more about dial pairs. I think this is a very, also QoS. I have actually the configuration here, so let's build on it. Okay, let's build on our VoIP configuration, not here, voice, yeah. So here we are configuring all this stuff, but we're not adding the most important configuration. Okay, this is up to this we know. This also we know. We use telephony service. We define the number of supported earphones. This is the number of extensions we can have. This is the source port. We define this auto assign 1 to 20. So auto assign 1 to 20. I think this command, if we have yeah, and then we just create the we create the DN, the directory number, and we add an extension number 10. Then we access this DN number, DN. Okay, then we add the IP and then the MAC address, and then the button. We link it with the button. Okay. My question is, what if we have just did this one, auto assign? We use this command 1 to 20. If we have used this command, would we have went through all this? Let us go and see. Try now. Go to telephony service. Okay, and type auto. Okay, assign. Okay, define a DN 1 to 20. 1 to 10, 1 to 1, auto assign 1 to 10, right? 1, okay, up to 10. Okay, let's now close this one. Okay. Yeah, so this command, this will automatically assign the, okay. Now this is what we missed actually, class map. This is very important actually. QoS on router, router class map, match any voice. Yeah, we have to assign this one. Okay, on one edge on the router we have to have this one. So let me go ahead on the router. Okay, this configuration is good for the quality class. This is for the one actually. This is, you can use this one if you are this is for outside, but for now we need for LAN, not for one, right? But the idea is same. Okay, we will just give the priority for voice and do this, but let's go ahead and do it for voice. QoS. Okay, this is the phone. Up to this we did this one. Just this part actually we didn't do, which I think we should do. Go ahead and do it. Not on the router, on the router or on the switch. I think switch we don't need. We just need to trust the device. Okay, so the only things that we need to do, if we have to add it on the packet tracer. QoS is limited. Configs work logically, not perfectly aligned. Okay, so the extension here is we just need to understand this concept, this idea. Okay, that's the whole point of this. If we understand this point, and we can close the doors, like we have to understand this one, QoS, and we have to understand what exactly each means, and then we can move on. Okay, I think we should finalize, and we are almost there. Okay, so I have to talk about QoS, because QoS is actually important. That appears a little bit, but QoS is more important. So okay, let's give you one example here. Like, think of your network like a highway system. Okay, the switch is the local on the RAM, and the router is the merging bottleneck on the main freeway. So let's consider the switch is like the traffic cop at the office. Okay, the switch is next to the user. The job is to spot VIP vehicles. Okay, so I want to open also the VoIP. What is the VoIP? This one also at the same time. But let me just close this one. We don't need this stuff. What we need is just there, so we can see the configuration and try to understand what we mean here. Okay, yeah, not this one. Let's talk about this one. Okay, and this one. No, okay, this one with the with this one. No, open this one on a new tab or a new window. Keep it in a new window. Okay, so we can see it side by side. We have dial peers, and we have what else we have? We have yeah, the lab. Yeah, so this is good. So now let's go ahead and put this here, and let's close this one. See, let's go ahead and do this one. Okay, so QoS and dial peers. Okay, let's go ahead and to the switch, for example, where we have the QoS. Yeah, see this QoS commands that I've configured in a switch, for example. Okay, it says MLS QoS trust device Cisco IP Cisco phone, MLS QoS trust COS. So what does this mean? Okay, so what this commands is saying is that, okay, it looks at the packets. Look, for example, the switch is right next to the user. Its job is to spot a VIP vehicle, okay, which means a voice packet. The moment they enter the road, make sure they aren't delayed by a garbage truck, like for example a large file download or print job. So how we identify it? The switch sees a device plugged in, okay, using CDP. CDP is used to discovery. It says, hey, you are a Cisco phone, I will give you a special lane. That's a voice VLAN, right? Then this part is this command. trust. It looks at the packet's VIP badge. The VIP badge is these DSCPEF and COS. Okay, so this two, the switch says, I see your badge, I won't strip it off, you're allowed to keep your priority status. Okay, the internal speed switch moves the traffic incredibly fast. Okay, the COP's main goal here is just to make sure the voice packet gets to the front of the line so it can reach the router without waiting behind the 1 GB Windows update. That's the idea. Okay, so it just, on the switch side, when you configure QoS, this is what you do. You're just doing this two commands or something like this, similar, but the idea is to trust COS and DSCPEF. Consider this as a marking. When a voice packet goes out of the phone, it's usually attached, marked with this DSCP or COS5. Okay, it's like a badge. Okay, that's how the switch identifies whether it's a voice packet or not. Okay, then the router. Okay, the router. However, in the router side, there is more configuration needed. Like the router is where the trouble happens. It usually connects your fast internal network to much slower internet branch link, maybe 50 MB. Okay, it's like merging 10 lanes traffic to merging one. So the bottleneck, when too much data arrives at once, the router has to store extra data in a parking lot called buffer. Okay, that's the router, what it does. Okay, so what it will do is it has a technology called low latency queuing. This is the gatekeeper's secret weapon. Even if the parking lot is full of thousands of data cars, the gatekeeper stands at the exit. The moment the voice car arrives, the gatekeeper stops all other traffic and pulls the voice car directly to the front of the exit line. That's the idea of low latency queuing. Okay, zero waiting time because voice conversation happens in real time. Any delay jitter makes a person sound like a robot. The gatekeeper ensures the voice packet spends almost 0 time sitting in the parking lot. Okay, so here you see this command. What we are doing here: class map match any voice. Okay, this is just a class map that I'm creating. I'm saying match IP DSCPEF. Okay, and then I'm creating a policy map QoS class voice. Okay, priority %30. I'm giving it higher priority. Then inside G01, I'm saying service policy output QoS. Okay, it's going to take from here. Okay, so first I created a class, okay, for voice, and I created then I created a policy QoS, okay, linked it with the class, and I mentioned the priority, and then I linked the one side, the port. I mentioned this command. So now I have improved the latency there. So this is it's just this commands. I don't think it will work on our packets tracer, but that's the idea. And dial peers, we've talked about it. Just like let's say you're connecting another CME router at a branch office or SIP provider. Like you can use dial peer here. Okay, like mention your destination pattern. Like this means basically if I dial a number starting with 2, okay, send it to the router at this IP. That's what we are saying. Session target IPv4, this one. Ensure touch tone works. Use code. This is basically what it means. Okay. It checks the pattern. It's like a routing table. Like we have to configure dial peers to, if we are configuring two different branches, connecting to different branches and stuff. Dial peers are required. Configure the pattern so it will forward to a different IP. Okay. So this that's all for voice, and I think we did. I explained most of the concepts thoroughly. We did it. We've seen it practically, and thank you for watching. See you on the next video.